Anyways, so what I was getting at there is that the 10 can divide out from here, and a 7 can divide out here, so I can have a 5 x to the power 4, and then 3 x to the power 2, or x to the power 5 plus x to the power 3. I put them in parentheses because, like I was saying before, I wanted to use an exponent quotient rule, and this is where I got stuck in the last video because I swear I can do it. Like, I swear I can simplify this more, and maybe I couldn't even simplify it like that, and I don't even know, but it's just like, I feel like this is wrong, but it's what I got. So I'm gonna keep going because that's what I got. So up here, this is just me doing the process that I got before, but now I'm gonna go over the process I did to get the chain rule of this one. Because like I said, it's 2 chain rules and then a product rule, which is why I hate this problem. So on this page, this is the first one I solved for, and I defined it as f of m of x like I did on the other problem. F of x being x to the power of 6, and m of x being 9x to the power of 2 plus 8. So f of x is x to the power of 6, f prime x is using the power rule, 6x to the power of 5. Then m of x is 9x to the power of 2 plus 8, and then I use the power rule to get the derivative, which is 18x. Now that I have that, I can use the fun little just regular derivative using the chain rule. So I did the derivative of f of x, and I put m of x in for x. So I get 6 because we have the 6 on the outside, and then I put this in for x, and then I have all that raised to the 5. So it's 6, and then 9x to the power 2 plus 8 raised to the power 5. And then I have to do multiplying that by the power, multiplying that by the derivative of m of x, which is 18x. So originally, if you look here, what I tried to do was distribute the 6 in and then distribute the 18x in, and it just like was not cool. So I ended up just multiplying the 18x by the 6 in the front, and I ended up with 108x times 9x squared plus 8 to the power of 5, which I feel like is okay. Because the more I simplify it, the more wrong I think it's going to get. So we're just going to leave it there. And then now that I have the derivative of like this part of the function and the derivative of that part of the function, I can actually use the product rule to do the derivative of the whole function, which is where I think it got like really messy, which is why I saved this one for the last one to go over. So I put, I didn't know how to like write this in right notation, but I did dy dx of f of m of x. That's the derivative of f of m of x, which is this part of the function, which is what was originally written in like the whatever equation it was that was given to me. And this is the part that was multiplied by this part. And then I did the same thing over here where I did the dy dx over h of g of x, and then I wrote the derivative of that part. I know that this is equal to like the derivative, but I don't know if that's the proper notation. I just like, it was just so much simpler than writing like the whole equation is equal to that. So anyways, now that I have that, I'm going to use the product rule, which is like the regular version of this. I'm sorry, I just really don't want to keep saying the variables. The regular equation of this times the derivative of that plus the regular version of this times the derivative of that. So that's what I did. I did this times this, and that's right here. We have this right here times this, all written right here, plus this times this. So again, that's written right there. All I did was I put this on the numerator of this when I multiplied it. I just skipped the step of writing this over 1. That's the only step I skipped when writing this, is that I didn't put the this over 1 and then putting it on the fraction. I just straight up wrote it on the numerator because that's where it's going. And if there's any errors in how I wrote it, I apologize. That's just how it happened. I'm rushing through this now. So then the only way I simplified this equation to get the derivative of like the whole thing, I think it was, yeah, it's p of x. So like the only way I simplified to get the derivative of p of x is that I moved this in front of this. And that's it. That's all I did. So like I didn't do any more simplifying. That's it. So yeah, it's this right here times this, like this being multiplied by this plus this fraction, and then that's the derivative. Super terribly written.